So today's topic, we are going to start with something that it's called rationalization. Rationalization is the mathematical procedure that we use to eliminate radicals from the denominator in an answer. Why do we need to eliminate the radicals in the denominator of an answer? That answer can vary for different stuff. Normally is that we kind of understand better like whole numbers in the denominator than radicals. So that's why sometimes people on the past used to rationalize the denominator. Now it's a common rule on math that we will always need to get rid of the radicals that are on the denominator part. So let's see today how to do rationalization when we have a monomial denominator. It says we need to multiply both numerator and denominator by the same term. Why we need to multiply both if we only want to modify the denominator? Remember that we have a specific expression, like it's an original expression. If we only modify the numerator or we only modify the denominator, we will be modifying the original expression. If I put the same quantity on the top and on the bottom part, it will be like adding a number 1, because the same number divided by itself, it's going to be 1. So it's like not modifying anything. And it says the specific term that we are going to put there is the term that completes the radical in the denominator part. So let's see how to do it with different examples. In example number 1, it's going to be very easy. We have the square root of 7x divided by 3y. In this case, we need to eliminate the 3y, or the square root of the 3y on the bottom part. We have a square root, and it says we need to complete the square root. That means, what do we need to have in order to be possible to take out the 3? Of course, we will need to have, in order to be possible to get outside the root, we will need to have another 3. Why another 3? Because 3 times 3 is going to be 3 squared, and that 3 squared will be possible to get outside the radical. And in the case of the letter y, it's going to be something very similar. We need also another y. Why we need another y? Because in this case, y multiplied by y will be y squared. It will go out from the root, and of course, everything will be go out of the root on the denominator part. Remember, the same term that I put, or I multiplied the denominator, I need to multiply also the numerator by that exact term. What will happen next? If I do that multiplication, of course, it's going to be, on the bottom part, it's going to be 3 squared y squared. On the top part, it's going to be 7 times 3, that it's 21xy. And in this case, it will be possible to take out from the denominator part. What will happen then? 1, and I will take out a 3 and a y. And on the inside part, I will still have 21xy. And if you check out, with this little process, we will be able to eliminate the root from the denominator. We will have only roots on the numerator part. Remember this one? Somebody can write it also as the square root of 21xy divided by 3y, because it's the same. So what we are doing here, and we are doing in every exercise today, is we need to complete the denominator root in order to be possible to take out that specific root. And of course, at the end of the answer, we won't have any roots or any radicals on the denominator. So let's see another example. So imagine in the next exercise, we have something like this. We have the cubic root of 2x divided by 3y squared. So in this case, remember, the idea is to complete the denominator root. In this case, remember, it's going to be a little bit different because we have a cubic root. So let's see how to complete. Of course, we need to multiply by a cubic root also. What do we need to have in order to get like a number or a letter to get out of a cubic root? Of course, it must have the cubic power, or the power to the 3. So in this case, we have a 3 to the 1. To become a 3 cubed, we will need to multiply it by a 3 squared. And in the case of the y squared, we need to multiply it by the y in order to become y cubed. And remember, if I put that specific term on the denominator, we need to put it also on the numerator part in order not to modify the original expression. Now we can combine both roots. It's going to be the cubic root of, on the bottom part, is going to be 3 cubed y cubed. On the top part, it's going to be 3 squared is 9 multiplied by 2. It's going to be 18xy. If we take out whatever we have in the denominator, it's going to be 1 dividing 3y that multiplies the cubic root of 18xy. So remember, this one can be an answer, or somebody else can put it as the cubic root of 18xy, all of it divided by 3y. So the idea is very simple, and it's the same on every exercise. We need to complete the root that it's on the denominator. In this case, it was a cubic root. That's why we need to have 3 cubed and y cubed in order to be possible to get out of the root. But the idea is going to be the same if we have a cubic root, a square root, a fifth root, whatever. We complete the denominator root, it will be possible to take out that part from the root, and in the final answer, we won't have any roots on the denominator. So let's see another exercise. So let's see. In this exercise, we have a little bigger numbers. On the denominator, we have a 16. So in this case, we also have a coefficient that it's multiplying the root. Don't worry, it's going to be almost exactly the same. So let's see. Of course, the coefficient won't change because it's outside the root. What will happen with the root? Maybe we can decompose it, and it's going to be 3a squared on top. That's already decomposed. But the 16, if we decompose the 16, it's going to be 2 to the 4 and b cubed. What happens next? Remember, we need to multiply by something. In this case, also a fifth root, to complete the root. So in this case, in order to be possible to get out from the root, they must have exactly the fifth power. So we have 2 to the 4 to become 2 to the 5. I need to multiply it by 2 to the 1 only, or 2, because 2 to the 4 and 2 to the 1, it's 2 to the 5. In the case of the b, we have b cubed. To become b to the 5, we need b squared. And remember, if we put it on the denominator, we need to put it also on the numerator in order not to modify the original expression. What will happen here? Of course, the coefficient stays the same. We can combine both roots into a single one, and it's going to be the fifth root. On top is going to be 2 that multiplies 3, that multiplies a squared, that multiplies b squared. And on the bottom part, it will be 2 to the 5, b to the 5. So what happens next? We are possible to take out something from the roots on the denominator. So it's going to be 8b squared divided by a that multiplies whatever we are possible to take out from the root. On the top, we are not possible to take out anything. On the bottom, we will be possible to take out a 2 and a b. And on the inside part of the root, we will still have 2 times 3, that is 6, a squared, b squared. What happens next in this case? We have a multiplication between the coefficients. So b squared and b, we can eliminate this b squared with this b. And my final answer is going to be only 8b divided by a that multiplies the fifth root of 6a squared b squared. I'm sorry, I forgot 8 divided by 2 it's 4, so it's not 8. This one should be 4b divided by a that multiplies the fifth root of 6a squared b squared, because 8 divided by 2 is 4. So in this case, that's the same idea for every exercise. We need to do the same process. We need to complete the root on the denominator in order to be possible to take it out. And in the final answer, we won't have any roots on the denominator. So let's see one last example. So in this example, it's going to be something like this: 3c squared divided by 2, that it's multiplying the 10 root of 64 a to the 10 b to the 5 divided by 243 c to the 15. So remember, we need to decompose the numbers that we have inside the root. So in this case, it's going to be the 10 root. If we decompose the 64, it's going to be 2 to the 6, a to the 10, b to the 5, all of it divided by 243. If we decompose it, it's going to be divided by 3, it's 81, divided by 3, it's 27, divided by 3, it's 9, 3, it's 3, divided by 3, it's 1. So it's going to be 3 to the 5 that multiplies c to the 15. So what can we do here? There are like two different processes that we can make. Some of the powers are bigger than the index, so we can start taking out the powers that are bigger than the index and then complete the powers on the denominator, or we can also complete it before taking it out, and after that take out whatever we can take out from the root. That's the possibility that you want to follow, because both will give you the same answer. So let's see how to do it without taking out anything before. So in this case, to complete the 10th root of the denominator, we have 3 to the 5 to become 3 to the 10. It's going to be 3 to the 5 also. In this case, c to the 15. 15 is bigger than 10. So we need to look for a number divisible by 10 in order to be possible to get out from the root. 20 is the next number that is divisible by 10. So if we have c to the 5, it's going to be on the bottom part c to the 20, and it will be possible to get out from the root. So what will happen? The same number, we need to put it on the numerator part. So what will happen is that we can combine both roots, and it's going to be the 10th root of 2 to the 6 that multiplies 3 to the 5, a to the 10, b to the 5, c to the 5. On the bottom part, it's going to be 3 to the 10, c to the 20. So let's see. It's possible to take out something from the roots. And of course, on the bottom part, we will be able to take out a 3 and a c squared, because 20 divided by 10 is 2. On the top part, we are possible to take out, in this case, an a. And on the inside part, what will happen? It's going to be, on the denominator, we take out everything, but in the denominator, we have 2 to the 6, we have 3 to the 5, we have b to the 5, and we have c to the 5. So what will happen here in this case? 3c squared and 3c squared. So our answer is going to be a divided by 2 that multiplies the 10th root of 2 to the 6 that multiplies 3 to the 5, b to the 5, c to the 5. Of course, maybe 2 to the 6 multiplying 3 to the 5, it's going to be a super big number. So if we don't have calculator, maybe we can left it like that. But if we have a calculator, maybe we can put the answer as a divided by 2 that multiplies the 10 root of 52, b to the 5, c to the 5. And that will be my answer. So in this case, as I was telling you, the idea on any exercise is the same. We need to complete the denominator root in order to be possible to get out everything from the denominator. And that way, it's going to be the called rationalization, that it's the mathematical process to eliminate radicals from the denominator. So thank you for listening to me. See you on the next video.